I love video games, especially sports video games. I can immerse myself for hours in a good sports-based video game. In addition to offering an opportunity to unwind, one of the things I love about sports-based video games is the immersive experience that those games provide. Getting to switch between different camera angles, viewing replays whenever I want to, looking at team or player and match statistics about my progress in real time, and being able to control how and when I consume all of these things. Not only is this a great way to have fun, it also helps me improve my technique. What if all of your sporting experiences look like this? Today I'd like to talk to you about a technology that already exists, which has all of the building blocks to make these kinds of experiences a reality. That technology is 5G, or the fifth generation of cellular network technology. My name is Mitch Beaumont. I'm a Principal Solutions Architect here at Amazon Web Services, and welcome to Going for Gold with 5G. Over the course of the next 30 minutes, I'm going to cover a lot of ground. Well, actually, since 5G uses air and radio waves, we're going to cover a lot of air. I'm going to start by introducing you to 5G and how it, in combination with some other technologies, promises to really change the game. Then, we'll take a deep dive into 5G and unpack some of the technologies that are core components of this next wave of innovation that are going to be powered by 5G. As we walk through those different technologies, we're going to explore some specific applications of 5G and how that technology is being used in sports today, and how it can be used in the future to deliver immersive experiences to sports fans, as well as provide the next generation of athletes with real-time insights into their performance. Don't forget, Brisbane 2032 will be here before we know it. And hopefully, some of what I'm going to share today with you will find its way into developing the next generation of gold medal winning athletes. Let's start by taking a walk down memory lane. And our journey starts all the way back in 1981, the year I was born. And it's from there that consumer handsets and cellular technologies have really evolved. It pains me to say that as a 1981 vintage, I had a friend whose mum, a travelling salesperson, had something not too dissimilar to that 1981 thing you can see there on the screen, installed in her car. Does anyone remember WAP, or Wireless Application Protocol? I do. And I did have a WAP-enabled handset there for a while. I remember using it to pull up the football scores. At the time, it was groundbreaking. This ability to get access to match scores whilst I was out on the go with just a mobile phone. This was the era of 2G, and it was awesome. If we fast forward to the 3G era, it was around this time that a shift started to happen and handsets started to move from just being about making voice calls to more of a tool for social connectivity. In the early days of 3G, we were able to enjoy data rates of up to about 14 megabits per second. Now, I'm not sure I ever got that though. Jumping into the era of 4G, something that many of us continue to use today, smartphone revolution was well and truly upon us. The first generations of 4G used something called LTE, or long-term evolution technology, to achieve theoretical data rates of between 10 megabits per second and 1 gigabit per second. These improvements led to reduced latency and improved voice and instant messaging capabilities, as well as the ability to stream high-definition video content, albeit with some buffering. And then we jump to now, the era of 5G, viewed by many as a step change in performance over 4G. The technologies which 5G encapsulates are really aiming to address a range of requirements from new and emerging application use cases. 5G has the potential to offer peak data rates of between 10 and 20 gigabits per second, significantly higher densities from a connection perspective, up to 1,000 devices per square kilometre in some cases, and single-digit latencies, as well as improved security. But do we get all of these things by simply switching on 5G or signing up for 5G with our local carrier? Well, the answer is a complicated one. There is more to 5G than meets the eye, and in a moment we'll take a deeper look at some of the components that make 5G such a game changer for anyone who enjoys watching, broadcasting, or partaking in sports. What makes 5G such an exciting step change for sports fans, content producers, and athletes isn't just 5G. In fact, in many respects, it's an alignment of the stars, a convergence, as it were. If we take our video game analogy, the immersive user experience is what really engages players. Whether that is the latest generation of graphics or immersive virtual or augmented reality experiences, advances in UX is what keeps us hooked. Then, We've got data. As a society, we are producing more data now than ever before. In fact, I recently read that around 2.5 quintillion bytes of data is created every day. Wow. From a sporting perspective, let's take a Formula One car as an example. The typical Formula One car produces between 2 and 3 terabytes of data per race. Each Formula One car is equipped with around 300 sensors and can generate more than 1.1 million data points per second. Now, getting all of that data from cars, or players, or stadiums reliably and within a time frame that allows builders to build the kinds of experiences that we as a population are coming to expect requires some serious horsepower in terms of connectivity. No pun intended. And this is where 5G and its constituent component technologies truly differentiate themselves from previous generations of cellular tech. 5G is fast. 5G offers ultra-low latency, and 5G can support an unrivaled number of connected devices. But it's important to remember that 5G alone doesn't provide all the things. But it is a fundamental enabler for moving data and delivering immersive, responsive, and engaging user experiences that are similar to those of a video game. I've mentioned content producers already, but I think it's important to emphasize that 5G provides a conduit through which content and/or data gets delivered. Much of that content is created by world-class media and entertainment companies from across the globe. And these companies are reinventing how they create content, optimize media supply chains, and compete for audience attention. AWS is helping these organizations drive this transformation for content creators, rights holders, producers, broadcasters, and distributors. We're doing this through industry-specific capabilities in each of the 5 priority solutions areas that are commonly identified by our media and entertainment customers. They are content production, media supply chain and archiving, broadcast, direct-to-consumer and streaming, and data science and analytics. But to better support these media and entertainment customers, AWS has launched the AWS for M&E initiative, which aligns AWS media services, AWS solutions, and other AWS service categories like compute, networking, analytics, and machine learning into one clear narrative to help our media and entertainment customers achieve their business outcomes across each of these 5 areas. Specific AWS services and tools highlighted at the launch of this program include the AWS Elemental family of services, Amazon Nimble Studio, Amazon IVS, and AWS ThinkBox. From a solutions perspective, we offer solutions like AWS Studio in the cloud, Media to Cloud, live streaming service, and video on demand service, and many more. It also includes partners like Dolby, Adobe, ArcXP, Autodesk, Dulux, Epic Games, and many, many more. With AWS for M&E, our customers can select the right services, solutions, and partners for their workloads to accelerate production launches and see faster time to value, which in a world of high-speed, low-latency connectivity that's powered by 5G is very, very important. Now that you understand how AWS is able to support our media and entertainment customers, many of whom play a key part in creating the content and the solutions that will deliver these next-generation sporting experiences, let's unpack 5G. By the end of this section, my aim is to help you understand that 5G is a combination of technologies which come together to provide the kinds of connectivity solutions that are going to support that next generation of sporting experience, content production, and, most importantly, preparing our athletes for the 2032 Olympics, which, by the way, starts on Friday the 23rd of July 2032. Let's start with Mmwave. Now, if you've been listening to the Australian telco companies like Optus and Telstra, or Spark in New Zealand, talk about their respective 5G offerings in recent years, you'd have no doubt heard of the term Mmwave, or millimetre wave. So what is it, and why does it matter? Is all 5G millimetre wave? Well, the term millimetre wave refers to a specific part of the radio frequency spectrum that sits between 24 GHz and 100 GHz. And it has a very short wavelength, a millimetre wavelength in fact. This section of the spectrum went pretty much unused by consumers for a long time, so millimetre wave technology aims to greatly increase the amount of bandwidth that's available to consumers by tapping into that unused spectrum. Lower frequencies, for example those that are on the left-hand side of the diagram, are more heavily congested with TV and radio signals, as well as the current 4G LTE networks, which typically sit between about 800 and 3000 MHz. The right-hand side of the spectrum is where millimeter wave sits, and this is where our connectivity can get a real turbocharge. Higher frequency transmissions have greater bandwidth, in other words, the data transfer capacity of network in bits per second. This means that with millimeter wave technology, a greater amount of data can be transferred per second, resulting in much higher network speeds. But there are some disadvantages to these higher frequencies, and we will unpack those in a moment. Can you imagine being able to watch a sporting event with thousands of other sports spectators at a stadium, and the moment a goal is scored or a point is awarded, you point your phone at the field and you're able to get real-time information about the game, the player, or maybe even see an instant replay of what has just happened. Another example of where the additional capacity has proven useful is in the world of content production. Sony has been enabling remote production of live events like sports, concerts and conferences without having to rely on OB trucks and satellite transmission. Now, if you're not sure what an OB truck is, don't worry, I'll come back to that shortly. These new approaches are leveraging the 5G networks and edge computing for producing live events and streaming high-fidelity video in both 4K and 8K formats to social media platforms, stadium jumbotrons, and distribution networks, also providing second screen experiences, anybody. Improved economics for live video production, enhanced distribution, performance and quality, as well as immersive and enhanced in-stadium experiences are just some of the benefits that have been realised by leveraging the 5G network in conjunction with edge compute capabilities. I promised I'd come back to OB trucks. OB trucks, or outside broadcast trucks, are dispatched to venues. Camera feeds from the side of the pitch are fed back to the OB truck. The production team edits the feed and transmits it back to the main broadcast centres. Now, I don't know the exact cost of an OB truck, but I think it's safe to assume they cost millions of dollars to build, and I would imagine the cost of an event would be in the tens of thousands of dollars per hour to operate. If you've been to any inner city venue of any kind, you can understand and appreciate that parking isn't always easy. Can you imagine trying to park one of these large OB trucks in a venue in the city? Reliable and performant connectivity from these venues using 5G could lead to a situation where OB trucks no longer need to be deployed to the venue. Does this potentially open up more venues for broadcast companies to work with? Currently, these companies need to rely on things like satellite or microwave links to get pictures from an OB truck. And if you could use 5G to get the signal out reliably, that both reduces the gear you need to bring to the venue and the cost. Just some food for thought. I mentioned earlier the high frequencies of millimeter wave do have some drawbacks. And the most significant of these is their range and strength, and the fact that they are strongly affected by pretty much anything that you put in the way. Trees, walls, buildings, and even moisture in the air. One of the component technologies of 5G that helps address this problem, especially in areas where there are plenty of obstacles, are small cells. Small cells are portable miniature base stations that require minimal power to operate and can be placed every 250 metres or so throughout a city. To prevent signals from being dropped, carriers could install thousands of these stations in a city to form a dense network that acts like a relay team, receiving signals from one base station and sending data to users at any other location. While traditional cell networks have also come to rely on an increased number of base stations, achieving 5G performance, the kind of performance which we've previously discussed, is going to require an even greater infrastructure investment. Luckily, antennas on small cells can be much smaller than traditional antennas if they were transmitting tiny millimeter waves. This size difference makes it even easier to stick cells on light poles and on top of buildings. This radically different network structure should provide more targeted and efficient use of the spectrum. Having more stations means that the frequencies that one station uses to connect with devices in one area can be reused by another station in a different area to serve another customer. Take, for example, large venues like sports complexes or concert halls where thousands of users need to connect within an enclosed area. In order to ensure all users maintain network coverage with good throughput, 5G small cells can be deployed in these facilities and surrounding areas to provide extra capacity so that the influx of users don't exhaust the network and cause signal degradation. After all, people are also an obstacle when it comes to millimeter waves. The team at YVBE wanted to create an immersive 360-degree video experience for fans. Their solution, a VR video platform, utilised 5G and AWS wavelength to stream live 8K ultra-high-definition video to sports fans and concert goers, allowing them to simultaneously choose various camera angles with ultra-low latency. With this solution, their customers were able to experience more enjoyable, lifelike experiences of sporting events, music concerts, and other high-grade entertainment programs. The next component technology that I want to talk about is MIMO, or Massive MIMO, multi-input, multi-output. Today's 4G base stations have dozens of ports for antennas that can handle all cellular traffic, 8 for transmitters and 4 for receivers. But 5G base stations can support about 100 ports, which means many more antennas can fit onto a single array. This capability means a base station could send and receive signals from many more users at once, increasing the capacity of mobile networks by, in some cases, a factor of 22 or greater. Massive multiple input, multiple output, or massive MIMO is an extension of the traditional MIMO technologies, which essentially groups together antennas at the transmitter and receiver to provide better throughput and better spectrum efficiency. Let's now take a look at how a new technology that's being developed by the team at ShotTracker is tapping into the 5G capabilities for benefits of sports fans, players, and coaching staff. The ShotTracker technology, a solution for testing how sensor-based technologies can transform the game of basketball in conjunction with 5G computing at the edge. The ShotTracker solution is made up of 3 different components: a ShotTracker-enabled basketball, player sensors, and anchors that get installed inside the rafters of the stadiums. Many leading companies are also creating basketballs and other sports balls that have this sensor-based or ShotTracker-based technology embedded into them. It's a small sensor, it's worn by players, it's about the size of a small box of matches, and it captures metrics from players and the ball and sends it back to a compute engine which sits at the 5G edge for processing. This information is then displayed on the ShotTracker application, and it includes things like box scores, zone charts, contested versus uncontested shots. All of this information comes in real time. This information flows to the coaches and to media partners and to fans themselves as well as the players. Let's now take a look at another technology called beamforming. Beamforming is a traffic signalling system for cellular base stations that identifies the most efficient data delivery route to a particular user, and it reduces interference for nearby users in the process. Depending on the situation and the technology, there are several ways for 5G networks to implement it. Beamforming can help massive MIMO arrays make more efficient use of the spectrum that's around them. The primary challenge for massive MIMO is to reduce interference whilst transmitting more information from many more antennas at once. At massive MIMO base stations, signal processing algorithms plot the best transmission route through the air to each user. Then, they can send individual data packets in many different directions, bouncing them off buildings and other objects in a precisely coordinated pattern. By choreographing the packet's movements and arrival time, beamforming allows many users and antennas on a massive MIMO array to exchange much more information at once. For millimeter waves, beamforming is primarily used to address a different set of problems. Cellular signals are easily blocked by objects and tend to weaken over long distances, as I've already mentioned. In this case, beamforming can help by focusing a signal in a concentrated beam that points only in the direction of a user, rather than broadcasting it in many different directions at once. This approach can strengthen the signal's chances of arriving intact and reduce interference for everyone else, to provide extra capacity so that the influx of users doesn't exhaust the network. As an example, the team at CrowdVision wanted to generate highly detailed pictures of crowds in public places, counting people in and out of the venue and whether those people were in queues or properly social distancing. As a sports fan attending an event, you'd be happy to know that these kinds of steps are being taken by the venues to help improve your experience. CrowdVision wanted to do this without installing long cables or on-premises servers. To achieve this, They use a new approach leveraging 5G networks and edge computing for streaming the sensor data and performing video analytics at the 5G edge. This led to improved operational efficiency with faster deployment of sensors, greater scalability, and in the future they hope to expand this to other use cases like security screening at airports and other venues. In case you're wondering, the reason 5G core networks will allow for reduced latency times is because of a technology called network slicing. Now, as the name implies, network slicing cuts the overall network bandwidth into chunks or lanes. It also provides a mechanism to manage those lanes individually and offers certain types of capabilities on those individual lanes. Now, what better way to show my age than to demonstrate this concept using Frogger? Frogger is a 1981 vintage video game, much like myself. For latency purposes, network slicing can ensure that certain lanes have less traffic than others. Think of them like the fast lanes on a freeway, thereby ensuring that data travelling on those lanes will do so without delay, hence the reductions in latency. As with the highway, you can't do this on every lane, and you may have to pay for the privilege of using those lanes. But at least standalone 5G networks with network slicing support this, and it will be an option. To demonstrate the power and speed of Optus's 5G network, Optus partnered with AWS and with the Walkinshaw Andretti United's Bathurst winning driver and current fastest lap record holder Chaz Mostert. From accelerating to steering, and even the driver's view, everything was connected in real time. We had drivers racing in real time from 200 kilometres away at an Optus store in the centre of Sydney, and we had hundreds of customers driving in location at Bathurst. What better way to bring the concept of latency to life than this?
We're here today in the Sydney CBD at the Optus store, where there is a race car sat on the track in Bathurst, being driven by a steering wheel and throttle inside the store.
When you're controlling a car that's over 200 kilometres away, having a low latency network is absolutely critical to keeping the car on the track.
At Optus, we want to bring to life 5G technology for our customers and not just demonstrate it in the labs. The technology that enables the future is right here at Optus, right now.
As you saw from the video, the AWS Deep Racer cars were equipped with additional high-definition cameras to provide the best user and driver experience possible. The video stream was broadcast from the cameras back to a central control console using Amazon's Chime SDK, or Software Development Kit. The Amazon Chime SDK is a set of real-time communications components that developers can use to quickly add messaging, audio, video, and screen sharing capabilities to their web and mobile applications. Hopefully through this session you've begun to understand how a convergence of technologies underpinned by 5G as a connectivity medium will have a game-changing impact on sports fans, broadcasters and athletes alike. With increased capacity and speed that millimetre wave offers, improved coverage that small cells and MIMO arrays bring and make possible, and security quality and improved security and network latency thanks to technologies like network slicing, you can see how the game really can get changed. As we've discussed today, organisations across the world are building new products and services to delight their customers leveraging 5G. 5G really can change the game, but not in a vacuum. At the start of this presentation, I talked about a convergence of user experience, data and connectivity. 5G provides the connectivity which is essential, but computation plays an equally important role in providing the kinds of experiences that I've been talking about. To continually support our customers, the builders, as they drive the innovation flywheel, AWS has taken steps to bring the cloud to where our customers need it, through the AWS Cloud Continuum. Whether that's in an AWS region, where we provide the broadest set of capabilities, or in an AWS wavelength zone, an AWS local zone, or an AWS outpost, where we bring AWS services closer to our customers to support their low latency use cases, or right at the edge in remote locations, on ships, in mines, and in any other location you can think of, with offerings like our Snow family of storage and compute devices. We've covered a lot of ground today, but there's always room for more. Unfortunately, I only have 30 minutes of airtime, but through the AWS Skills Builder, we've got over 500 digital courses and learning plans that you can use to level up your knowledge about building the next generation of great sporting experiences on top of 5G. And to help decorate your championship wall, as every great sporting club must have, you can sit one of our industry-recognised certifications. Be sure to scan the QR codes to get more information. Thank you for joining today's session. It has been a pleasure to talk to you about how 5G is and will continue to support the next generation of sporting experiences. Whether you're a fan, a content producer, or an athlete preparing for Brisbane in 2032, low latency, high-speed 5G-based solutions will very likely play a big part in your journey. If you've enjoyed today's session, please don't forget to fill out the session survey. This helps us continually improve the content that we create for you, our awesome customers. Stay safe.